Hi, everyone, and welcome to Submodule 2.3. This presentation presents a case study site regarding the integration of ground source heat pumps into the built environment and particularly into historical buildings. The project that we're going to talk about was the refurbishment and retrofit of one of the oldest and most historical buildings in Dublin city centre. So you can see a picture of the building here on the right-hand side of the slide as it is today. But historically, the building was actually part of a quadrangle, which was first completed in 1699. And you can see that in the 1800s and also in the 1950s, the building actually underwent a significant amount of refurbishment. And in particular, in um, the 1850s, sorry, the connecting ends were demolished and turning this into a standalone building. So as part of the project, there was a rather intensive design process to look at implementing fabric improvement measures and selecting new heating and domestic hot water technologies for the refurbishment in order to reduce the CO2 emissions and increase the efficiency of the building. And you can see here some of the measures that were considered as part of the early design process, which looked at a holistic approach, looking at the conservation impact, the fabric impact, the embodied carbon, and the CO2 emissions, but also considered the constructability of the project and then the final architectural and visual impact in a very, very sensitive location. So some of the measures that were selected included fabric upgrades, which included upgrades to the outside rendering of some of the walls, the inclusion of GeoServ or recycled glass insulation in the suspended floor spaces, which you can see in the picture on the right there. And then also the improvement of the roof insulation. The roof was actually completely redone as part of this project. And finally, during the course of the initial design, ground source heat pumps were found to be the lowest running cost and maximizing the CO2 emission reductions for a potential highest energy contribution. So as part of that process, then it is really, really important to consider the energy demand of the building, particularly in a difficult building like this, which you have seen from the previous slides, has had many interventions, has had many different building and fabric materials included as part of its history. So the default generally in the design process is to carry out a steady state calculation which provides an energy demand profile. But typically, the disadvantages of this is that it tends to oversize a building and it doesn't really reflect correctly the energy demand, which includes all of the external factors, the solar gains, the heat gains, the thermal mass of the building, and the actual usage. So, as part of the design process, a dynamic simulation for this building was undertaken, and this was used to combine all of the building fabrics, including measurements of hygrothermal surveys of the specific U values of different building elements to determine what the energy demand profile would be once the building was refurbished. And you can see here, this is the output, let's say, of that process, which allowed us to come up with a space heating demand profile, a domestic hot water profile, and a peak installed capacity requirement for the building in the coldest day of the year. And broadly, that dynamic building assessment approach prevents oversizing. It reduces the impact that the building would have in terms of the intervention measures would have on the building and its surroundings. More importantly, it maximizes the performance of the system and ensures very high comfort levels.